Officials at Mar Farms say they have been working to meet many of the energy and environmental problems created by modern industry. They claim to be developing farming techniques which will not be wasteful and will enhance the environment. At Mar Farms, a variety of crops are produced which are interdependent on each other. For instance, a variety of tropical fish which has become very popular in Southern California, tilapia, is one crop farmed at Mar. Tilapia is a tropical fish from North Africa that is similar to perch. Waste from the tilapia is used to produce a variety of greens and watercress. The water is then refiltered and used again. They say the fish waste organically improves the water, giving it a chemical balance that must be present to grow certain plants. This, they say, is a natural way of using natural methods to add nutrients to the water for the production of the various greens they raise. They describe their system as an aquatic system rather than a hydroponic one. Tor Ewald pointed to the brine shrimp and other living organisms in the grow-out runs where the plants are raised. The quality and condition of the water is constantly being checked in a laboratory. It's claimed this operation uses not 50% less, but rather 50 times less water than any other comparable operation as a result of its practices. Ewald says the farm is situated in San Diego County near the coast because of the constant source of sunlight and the proximity near the ocean, which acts as a thermal sink, maintaining a constant pressure. Ewald also claims this complex is now producing 2,500 cases of watercress a week. Ultimately, he added it's hoped that production can be expanded to 4,000 cases a week. Photovoltaic cells are used to convert light into energy. That's another objective at this farm, Ewald says, to produce electric and thermal power. They've experimented with approximately 17 different crops to come up with the ones now being produced. Ewald describes the steps in the farm's operations to achieve their objectives.
Tilapia is our fish crop that we're doing. It's from Africa, actually is where it's from.
What other purpose do they serve other than provide nutrition for your vegetable crop?
Well, the fish is a production crop that we actually sell to fish brokers.
Okay, that's why.
And actually provide us with income.
And so it would be for breeding or for food, or both?
Well, generally for food. Our breeders are actually of a different strain than the production fish. So we do a hybrid of tilapia.
So what is the process now? What takes place? We see where the fish are growing.
Okay.
You've got your tanks. Right.
We stock our tanks with our fish, and the fish are fed a food, a protein-based soybean meal. We also add lettuce roots and things like that. And the fish then provide us with a nutrient-rich water resource.
Okay.
That water goes through some settling tanks. And then
we see outside the building where the fish are kept, we see this one tank. And how do you define that? The water comes through that, and it is what?
The water, after it leaves the fish tanks, goes through some settling process where we're settling the solid waste material from the water so that we don't accumulate solids in the growing raceways, is what we call them.
And then the water goes from there into where we see all of these huge plants.
Right.
And in many instances, that's a plant you never want to grow wild in your lakes or your streams, right? Hyacinth.
Right. Over there, what we have is the water hyacinth, which is extracting all that nutrient that the fish are putting into the water, so the water is able to return to the hatchery and is reused again.
And you said that by the time the water reaches the other end of this tank here, or this building,
right,
it is purified by the hyacinth. Is that correct?
Pretty much. You are able to. It has taken out much of the waste that the fish have put into it, and much of the water that is in that system has been there for about a year now.
And it is just pulling up one of these hyacinths. Their root systems
are immense.
Yeah,
they're amazing. Water hyacinth next to kelp is probably the fastest growing plant on the planet, because of that root system and its
Tremendous
metabolism.
biomass, isn't it?
It's fantastic. It is.
And in back of you, you've got these huge tanks with these cells. What kind of cells are they?
Well, floating on top of the fish tank is what is called a photovoltaic generator.
Which is?
These photovoltaic generators create electricity and hot water from sunlight. These photovoltaic cells, or solar cells, are very similar to those that are in solar watches and calculators. And they're able to provide us with electricity and hot water from the sun, which reduce the operating costs of the fish tanks. They're providing electricity to run pumps and blowers, and hot water to increase the water temperature, which helps the production of fish.
And it is here that the fish are harvested for sale, right?
That's correct, right. The fish will stay in here, depending on what temperature we keep the water at, anywhere from 10 months to a year.
And the water then is circulated over to grow your vegetable crop, right?
That's correct. The water goes through a settling process where we try and remove as much of the solid waste as we can. And then all of that fish water, which is very high in organic nutrients, goes over to what we call our raceways, where we are literally floating our produce in the water, and the roots are able to extract all of that organic nutrient from the water. As the water goes through all the systems, it becomes clean and is
returned back to the fish tank.
Right back to the fish, exactly.
Hence your reference to your aquatic system and your life support system, right?
Exactly. We call this an integrated life system because we are indeed integrating two different life systems together, the fish being one and the plants being another. And it is an aquatic system because everything is grown in water.
Yeah, but there's a great distinction between hydroponic and what you call your aquatic system.
Definitely. Traditional hydroponics is you are using water. However, what you are doing are adding petrochemicals to your water. You grow your crop. After a crop or two, your water becomes too high in salt. You then dump your water. You clean the system. You make it aseptic. And then you start all over again, which is very different from what we do here. Everything is recycled and left in a natural state.
I noticed, too, that there are all kinds of life forms beneath the plants that are growing here. You see the brine shrimp. You see a variety of life.
It's an aquatic zoo. It really is.
And you say that's healthy.
Actually, yeah, we're finding that does create a natural equilibrium in the system. We're kind of working on one of the natural laws of when you have diversity, you have a lot of stability. So the more creatures we have in the system, we find it is very easy to keep in that equilibrium.
It becomes less threatened the more the critters, huh?
You might put it that way.
Less threatening.
Yeah.
And you say this is one of the stages, probably in its infancy, of what is going to be required for life support systems in space?
Right. One of the long-term goals that we have here is developing systems for extraterrestrial activity, lunar stations, space bases. When you are operating in space, you are operating in a giant capsule. You have to become very well versed in recycling systems, recycling your water, renewable energy, making electricity from sunlight, processing your waste, processing your waters. So this is the beginning of that kind of technology.
There are 3 acres of actual growing area at Del Mar Farms. Ewald claims this has been a learn-as-you-go proposition. One of those involved with the research project at Del Mar Farms is Bob Boylan, a biologist-chemist who became involved with the project at the very beginning. He says nobody else is doing this sort of thing, adding there was no textbook to consult to see if you're doing the right thing.
What we've tried to do in developing all our technologies is to walk as lightly as possible on the land that we use. And consequently, we've done things that are as close to possible as using all the resources within the system. Everything is recycled, including nutrients, including water, and being as energy efficient as possible and all of those things.
What have been some of the major problems in accomplishing this? And what are your ultimate objectives?
Well, let's talk about the farm. Some of the major problems on the farm is we're doing things that haven't been done before, as Tor had mentioned. One of them in particular is we're working in systems that are equilibrium systems. And for most of the hydroponic work that's been done in the past, it's been done with sterile system, or as sterile as possible systems.
Yeah, but you're different. You call yourself an aquatic system, right?
We're an aquatic system, and we call it that to distinguish it from hydroponic, because we're looking at a biologically equilibrated system, where hopefully everything is in balance.
Okay, and where everything lives in harmony, I suppose. Is that...
Yes, and to answer your question, occasionally things do get non-harmonious.
Sure.
And
fungus,
at that
bacteria,
time,
is that it?
Yeah, fungus,
Yes.
bacteria,
Yes, it
and
runs
insects. Something comes into the system that hasn't been there before. It doesn't have its natural predator, and we have to search around to try to find something to keep it into balance.
Still maintain that balance. Have you lost crops
yeah.
as a result?
We have. Yes.
You have?
Yes. Our first few years were rather difficult because of that. We're now reaching a more stable environment. Things are in more equilibrium, and we're not being surprised as often.
What are your objectives now?
Our objectives are to bring this farm to maturation so we can grow a large number of different crops in this way.
Using a minimum amount of water and doing it using natural energy and in a natural environment. Is that
using natural nutrients. We're also interested in tying this into a larger farm concept where we use animals such as chickens and ducks, where we recycle all of our produce through our system and have a minimum amount of materials coming in from the outside. It also includes energy development. It includes alcohol fuel production, biogas generation, and a whole bunch of other sidelines that we think are going to be part of the farm of the future. Right? We think the farm in the future is not going to be a farm that grows a single crop in the soil. It's going to be a farm that grows a number of different crops that are integrated in such a way that there's nutritional conservation, there's water conservation, and space conservation.
And as you put it, an integrated life system.
An integrated life system, yes.
Ewald says he and his staff are not only trying to develop new farming and energy concepts, but that they're red-blooded American capitalists out to earn a buck. He added, we're also trying to work with planet Earth rather than against it. For the Voice of Agriculture, I'm Bill Evans reporting from San Diego County.